Hello everyone, welcome back. This is Dr. Gallenstein, and today we are going to be looking at the decision making of firms and production. Okay, so we're looking at production and the decision making of firms. Okay, so far in the class we have talked about individual decision makers, pretty much consumers. That is, how do consumers make decisions as to what they will purchase or what actions they will take? We have noticed, or we've developed models of the decision making of consumers based on utility. We say that we model individual preferences using a utility function, and we say that individuals will maximize their utility subject to some constraint, or they will minimize their expenditures subject to some level of utility. Okay, well now we're moving beyond that, and we are going into basically the other side of the economy. So we showed how that we can kind of generate the demand side of the economy by looking at the utility maximization or expenditure minimization process of consumers or individuals. Now we want to look at the other side of the economy. We're going to kind of look into the supply of goods, and we're going to look at the decision making of firms. Firms are economic agents that produce goods. Okay, so we're looking at production decisions or firm decisions. Now, just as with individuals, where we had expenditure minimization, so with individuals, with consumers, we had maximizing utility, or we had minimizing expenditures. With production, so with firms will maximize profits, or they will minimize costs. All right, but in this class, we're only going to talk about profit maximization. So that's what we're going to do today. We're going to look at profit maximization and the decision making of firms. All right, so without further ado, let's begin looking at profit maximization. Profit maximization. Okay, now, how do firms make decisions? Well, what they do is they make decisions so as to maximize their profits. So they will choose the quantity that they produce, which we label Q. So they will choose whatever value Q, the quantity produced, so as to maximize their profits, which I'm going to represent with the letter pi here. So I'm going to say that pi of Q is their profit function. Profit function. The profit function is a function of, the quantity the firm produces. Okay, so that's what we're going to look at. We're going to look at this maximization problem here. Firms are going to choose the quantity that they produce so as to maximize their profits. All right, so with that in mind, let us begin to explore what this profit function is. So what is this profit function? Well, the profit function is composed of two component functions. The first component is revenue, which I'm going to represent with the letter R here. So this is the revenue function. Okay. So profits are composed of revenue, that is how much money the firm is bringing in from the sales of what they produce. Okay, minus cost. So we have the cost function. That is the cost function. This is how much it costs the firm to produce the quantity of goods Q. Okay, so this is the revenue is basically the money coming in and the cost is the money going out. All right, so the money is, so the cost is how much it costs them to produce the good Q, and the revenue is how much money they make from the good Q. Okay, so that's profit maximization. That's how we model the decision making of firms. Okay, so let's talk a little bit about how firms will make their decision by maximizing their profits. Okay, first let's get a little bit of a visualization here. So let's say we have a graph and has profits on the y-axis and quantity produced on the x-axis. Okay, and so now let's plot out the firm's profits. Now we might expect that the firm's profits might look something like this. Okay, so then we can say, well, where do they maximize profits? At what value of Q does the firm maximize their profits? Well, profits reach their maximum right around here, okay? And that will correspond to a particular quantity, which we will call Q star. So the firm will choose to produce this quantity of goods so that they can achieve the maximum level of profit. Now you'll notice, just as with utility, the maximum profit exists where the derivative or the slope is equal to 0. So the slope equals 0. Okay, so then how will we go about finding what the profit maximizing Q is? Well, we will use the same methodologies that we used for the individual decision-making process or the utility maximization process. We'll use the same tools because we're doing effectively the same thing. We want to find the quantity produced that will give the firm the maximum amount of profits. Okay? And so we're going to use the same methods as before. So let's do that. Let's lay that out. Okay, so what we are going to choose a quantity to produce Q so as to maximize the profits. All right, and profits is revenue minus cost. Okay, so then how do we go about doing it? Well, we follow a similar procedure as we did with utility maximization. That means we find our first order conditions and we solve those first order conditions for the optimal Q. Now, one thing that you'll notice here is that I have not specified any constraints. I haven't specified a constraint. Well, for profit maximization, we typically don't have a constraint. In fact, basically, the constraint's kind of built in because this constraint is the cost function. Now, there could be scenarios in which we do put a constraint, but we're not going to see any of those scenarios here. So we don't have a constraint. That means the maximization process is a little bit more straightforward. So let's do it generically first, and then we can do an example in a moment. Okay, and when I say generically, that just means that I'm not specifying what the revenue function is, and I'm not specifying what the cost function is. Right now, I'm just saying it's some function R of Q and C of Q. Okay, so when I say generic, I just mean that I haven't specified exactly what the function is. Okay, so let's do our maximization. Now we know the first thing we need to do is find the first order conditions. That means we take the derivative of the profit function with respect to Q. All right. So we take the derivative of the profit function with respect to Q. That means with respect to whatever it is, whatever our choice variable is. Whatever our choice variable is, we take the derivative with respect to that. Okay, so this is straightforward. If we took the derivative of this with respect to Q, we'll just go term by term. So what is the derivative of the revenue function with respect to Q? Well, we will just simply write out, just generically, derivative of R with respect to Q. Okay, and then what's the derivative of the cost function? Well, again, we're just doing it generically, so it's quite simple. The derivative of cost with respect to Q. And this is a first order condition, so we set this equal to 0. Okay, now what we would do if we wanted to find Q, so we would find Q star by solving the first order condition for Q. Okay, that means that Q star, so Q, I'm just going to write this out. Q star is the value of Q such that the first order condition is true. Okay, so whatever value of Q makes it such that this equation holds, that is Q star. Now, it's right here that I want to dive deeper. Why are we doing it generically first? Well, I think generically is going to help us to understand the intuition of the firm's decision-making process. Okay, so let's take this deeper. What does this equation mean? What does this equation here mean? All right, well, let me do some erasing, and then we will explore this. Okay, so what we're going to do is I just want to get some intuition on the decision-making process of the firm. All right, I want to get some intuition on the decision-making process of the firm. All right, so what we're saying is that the optimal quantity produced is the quantity produced such that the first order condition holds. All right, such that that equation is true. Well, let's break this down. What does this equation mean? All right, well, the first thing we can look at is we can look for the marginal benefit and the marginal cost of the decision. All right, now let's just think about this intuitively. What's the marginal benefit of an additional, so what is the benefit of an additional unit of quantity produced, of Q? What's the benefit of one more Q? If the firm produces one more Q, what is the benefit to the firm? Well, the benefit to the firm is the amount of revenue that it generates from that additional Q. Well, that is captured by this term here. This is the marginal benefit. This is how much revenue increases given an increase, a 1 unit increase in Q. Okay, so this is, so we actually can give it another name. It's the marginal benefit, yes. We can say this is the marginal revenue. That is how much revenue goes up given a 1 unit change in the quantity produced. Okay, so that's the marginal revenue. The marginal revenue is the marginal benefit of production. Okay, well, what about marginal cost? Or what about, I should say, yeah, what is, there's a marginal benefit and there's a marginal cost. Well, what's the marginal cost? The marginal cost is how an increase in Q changes the cost to the firm. Okay, so this is the marginal cost. So that is, how does the cost change given a 1 unit increase in the quantity produced? Okay, so this is the marginal cost. Marginal cost. Okay, so now going back to early in the class, the fundamental intuition is that rational agents make decisions on the margin, and they make decisions such that the marginal benefit will equal the marginal cost. Okay, so let's just rearrange this equation. So the optimal value of Q will be whatever quantity produced allows the marginal benefit to equal the marginal cost. Why is that? Let's just think back to our intuition. If the marginal benefit was ever larger than the marginal cost, then the firm could make more profits by producing more. Likewise, if the marginal cost was ever larger than the marginal benefit, then the firm could make additional profits by producing less. Therefore, the firm achieves the optimal, the maximum profits at exactly the quantity that equates the marginal benefit with the marginal cost. Okay? And that's captured in the first order condition. In the first order condition, the first order condition captures this truth. We find the optimal quantity. We find Q star by solving the first order condition for Q. All right. That means that Q star is the value of Q such that the marginal benefit will equal the marginal cost. All right. So that's our fundamental intuition on firm decision making. Now let's give a little bit more details and let's do an example problem. All right. So what we're going to do here is we're going to specify our function. So we said here that the profit function is equal to revenue minus cost. Okay. Well, let's specify what the actual functions are, and then maybe we can solve out a problem. Okay, so the revenue function is rather straightforward. The revenue function is simply this. The amount of money that the firm makes from the amount that it produces is equal to whatever price they sell their good for times how much of that good they produce. So the revenue function is very straightforward. It is just price times quantity. Then the cost function. Well, the cost function is going to vary. It doesn't have a single or particularly intuitive functional form. And so if you're ever solving a profit maximization problem, you'll need to just take whatever functional form is given to you. With that said, let's go ahead and solve a profit maximization problem where I will specify what these functions are. So let's say the revenue function again is price times quantity, and the cost function, and I'm just going to say that the cost function is 2 times Q squared plus 100. Okay, and in fact, I'm even going to give you some more details. I'm going to tell you what the price is. I'm going to say that the price is 50. Okay, oops, it's just 50 times Q. Okay, so here we have a revenue function or cost function. Let's do a profit maximization problem. So the firm will choose Q to maximize their profits. Their profits are revenue minus cost. Now be careful. You minus the whole cost function, it means 2Q squared minus 100. All right, you subtract the whole cost function. So let's do this. First order condition. We take the derivative of this with respect to Q. So the derivative of the profit function with respect to Q. Let's go term by term. First term here. What's the derivative of 50 times Q? It's 50. All right, next term. What's the derivative of negative 2Q squared? It'll be minus 4Q. Next term, what's the derivative of 100? Well, there's no Q there. That means we know the derivative is 0. All right, let's set this equal to 0. And then let's solve this. Let's solve this for Q. You know what? Now that we're getting down here, I'm just going to change what the price is to make the math easier. Let's say that the price is 40 instead. Let's say the price is 40. That'll make the math easier. And this is just going to be simple. All right, there we go. Hope you don't mind that. Okay, so now let's solve this for Q. Actually, you know what? First, let's go ahead and label. This is our first order condition. Let's just do some intuition here. What is the marginal benefit? The marginal benefit is the marginal revenue. What's the marginal revenue? That is, how much more revenue does the firm get when it increases production? I gotta change this one. When it increases production, how much more revenue does it get? Well, it gets 40. For each additional increase in the quantity Q, revenue goes up by 40. All right, what's the marginal cost? The marginal cost is here. It's 4Q. This is the marginal cost. It means every time that you add one additional quantity produced Q, you will face a cost of 4 times that quantity. All right, so that means the firm will choose the optimal quantity such that the marginal benefit equals the marginal cost. So it will choose the quantity Q such that the marginal benefit equals the marginal cost. All right, so that's how we're going to solve this thing. That's how we're going to solve this. So we're going to find the value of Q such that the marginal benefit equals the marginal cost. Well, what is the value of Q? Well, we'll divide both sides by 4, get Q, isolate Q. All right, and so what we'll get is 10 equals Q. I'm just going to rearrange. So this will be Q star, our optimal Q is 10. The firm maximizes its profits by producing a quantity of 10. All right, a quantity of 10 is the value of Q such that the marginal benefit equals the marginal cost. Okay, there we go. So that is profit maximization. That is the simple presentation of profit maximization. In the next lecture, we'll go into a little bit more detail. We'll take the profit maximization, the firm decision, a little bit deeper. Until then, I hope that you have